All right, fantastic. Hey everyone, my name is Gabe and I'll be speaking to you about the challenges and opportunities working with battery data. So now, this is, I'll say, time now for something completely different from your regularly scheduled grid energy. But it does relate, and I will tell you how. So first, so the way kind of this presentation will work, we don't have a ton of time, but I'll give you a quick overview, a quick summary of the battery industry, and then kind of an introduction of what the battery industry is, and how it interacts with the grid, and then how you can help and cross that gap. So real quickly about me. So I'm the chairperson for the Battery Data Alliance. That is a project within LF Energy. I'm also the board member from the Volta Foundation, which is a trade association for the battery industry. So that's kind of where I come from. And then I also founded a battery observability and data exchange, a battery software company called AmpLabs. So I basically live and breathe this stuff all the time. And then in addition, I've about over 10 years plus experience working in data platforms as well as capacity planning for cloud enterprise. So also on the consumption side. A little bit about that later. So that's about me, but about the battery industry. So when we talk about the battery industry, I want to be clear, we're not talking the consumer electronics space. We're primarily focusing on two categories, a passenger vehicle and a battery energy storage system. So some of these slides, some of the more, like I said, the high-res slides, are part of the work I do in the Volta Foundation. We produce an annual report called the Battery Report. I welcome you all to take a read of it. It basically breaks down the industry for newcomers or long-time participants and to understand how batteries are made, who's using them, who are the big players to keep in mind, and how to kind of get up and ready to work in the industry, actually. So the focus here is that there's, you can see on these two graphs of passenger vehicles, the growth of battery consumption is increasing year over year, primarily driven by China. And similarly for battery energy storage systems, there's increased investment. It's tripled since 2021, and it's anticipated to go to 120 or 150 billion by 2030. So here's just a sense that batteries, there's a large demand for batteries around the world. And next, here's a little synopsis of the supply that's being produced around the world, focusing on Europe here. But you can see most of it will be produced, as you imagine, from China to satisfy its own demand. So that's the demand. There's the supply. And then when we talk about the battery industry, we largely talk about the battery value chain. And so this is what we mean by that. We break it down in our annual battery report by the different sections of the battery value chain. On the left, you have mining, basically of the raw materials. You have the material processing, the cell construction, package and modeling, modules, and then assembly, and then probably the most interesting for a lot of the headlines is the end users with cars or big energy storage. But when we think of the battery value chain, we think of the whole end-to-end whole pie there. When we talk about battery software, we're largely talking about sections in here. So there's software across the entire value chain, but in particular, battery management systems are largely entirely software. And I think that's actually where the most interesting work working with the grid comes in. Yeah. And what's also interesting with the battery value chain is its cross-functional nature. So when we build these batteries, these larger batteries, it is, as mentioned in the previous talk, that the most expensive component of the battery of these other systems, let's say passenger vehicles, is the battery itself. So any improvement made in the battery influences other industries as well. So there's a circular nature of improvements in one supporting the other. So as we're going in terms of decarbonization or electrification of the grid, we should keep in mind improvements being made in the battery industry. There's also talk of, when we talk about, let's say, a green industry, we have to mine new materials to make these batteries, but then we talk about second life of the batteries, but also recycling, battery recycling, that if we have chemistries that can then be more of the components can be recycled, that also plays a factor here. So it's good to keep in mind that the value chain is not just one direction where it's just outputting batteries, it's circular in nature, and they help one another. Real quickly, now to get into battery software, and I'm going to kind of go through these next few pretty quickly. It's good to understand that there's 4 key categories for battery software, with design, and these kind of match what we saw earlier, but this will come back. Design and analytics, process control, manufacturing, and in-field analytics. You can imagine that's crossing from when the cell is first being designed in the lab to as it's matured into process and actually out the door. The requirements of which are kind of broken down as such. So, and this is where it comes into, we talk a lot about data and the willingness for data sharing. So in these categories, there's different kind of personas or profiles you can imagine. All data is not created equal, but you can, and the people who are working in those spaces have different requirements of their data. For just real quickly, and design R&D is the highest willingness to share, whereas people who are actually building the batteries don't actually want to share their data per se, because it may influence, appear poorly on them. But I think actually in the in-field analytics is actually the most interesting for this group, and actually is the most untapped area in terms of open source, and actually is a pure opportunity that I would want, which is actually the reason we started Battery Data Alliance, is to get people interested in this area. So some of it is social in nature of the way the ecosystem is built, but we do think open source is a way to kind of break down these barriers. If we create avenues where people are more willing to share, make it easy for them to share while maintaining their privacy and controls, we can turn everything from low to a very high willingness to share through this model. So real quickly, the problem as stated, there's no clear standards, redundant work, lack of collaboration equals slow progress. And kind of the solution and articulation of that problem, I was mentioning, so here's a really nice slide from the Battery Data Genomes work done by a series of organizations around the world, actually, largely driven by national labs, and where it's looking for kind of the industry component added to it. And I think of the Battery Data Alliance as the industry answer to go along with the Battery Data Genome. So basically, as it stated, quoted from the paper, the primary roadblock to a battery data science renaissance is the requirement for large amounts of high-quality data, which are not available in the current fragmented ecosystem. And I can jump to the solution, is what's actually building strong community, open source practices. Open source software best practices will actually create safer and cheaper batteries and a greener planet. And this is the solution as presented in the Battery Data Genome, is that the 4 key areas, if you think of battery development from cell design to actually when it gets out to the field, there's 4 key areas: cell manufacturing, fundamental material electrode data, field data, module pack data. I want one thing people, I'm nearing the end of time here, but I want people to keep in mind of the grid deployment. There is very high value data being generated in the grid deployments that today are not making its way back to cell manufacturers or researchers. Something as simple as common test protocols is very helpful for people who are building new cells to then know that's basically input from their users. Like, well, how are you actually going to use this machine? The more I know about what you're going to do with it, I can build you a better battery. So I think that this is probably, this is from the Battery Data Genome, and I think it applies directly into what we talk about here. There's examples of the software used in the Battery Data Genome. I worked largely with the Battery Archive project of how to get, and these projects are all open source, but these are all built by kind of research organizations. But what entered is the Battery Data Alliance, which was formed from battery data companies who wanted to work together to kind of build the concept of the Battery Data Genome, but ready for enterprise, ready to put to work. So we have a few software projects of note. The BAT-ETL, BAT-DB, both donated by BAT-Genie, which are ETL tools for battery test data. PyAdmiral, PyCTI, Arbin, PyMacNet. These are controllers of battery test hardware. If you have questions on those, I'd love to, we could talk at length about the battery test hardware. And the BDA ontology, which I'll talk about in a little bit. I mentioned BAT-ETL. I think there's probably, most people here know ETL tools. This was basically focused for battery test data. The hardware unit, to build connectors into test hardware, we have collaborations with actual hardware companies who've actually donated hardware to the BDA, Battery Data Alliance, and lab space was donated for us to actually house the testers, which is very critical. Battery data ontology, I'm actually the most excited about, is the newest addition, where when we started the project, we thought we had to build a whole library of connectors. But the battery data ontology, which is a project from the BAT-Info, led by Syntef in Norway, they've done a lot of work already building these linked data primers. Basically, they map out the battery, their ontology of how the components of a battery are already defined in software. And if we can map our formats to the ontology, we don't have to write custom connectors, which is a huge relief from a project perspective. There's any number of cycler hardware, but if we can build adoption of the ontology, we get translation for free, basically. So great. And then here's our version of basically the battery data genome, which was largely academic in nature. We've then are building out a version that is a collaboration of basically for-profit entities who are collaborating in open source to produce our equivalent of that framework here. And of course, if the Battery Data Alliance is unlocking all the buzzwords, AI, ML, digital twin, sure, everything under the sun, of course. But all the companies here are all active members of the Battery Data Alliance helping to build this vision. So again, key takeaways here, if you have learned anything about batteries, is to know that battery demand is growing, the global battery production is growing to meet it, software and data is needed to support the battery value chain. The Battery Data Alliance is where battery data companies and labs are collaborating on open source projects in a vendor-neutral home. And of course, we need your support. So thank you. Thank you all. I think that's it. I think we're at the break now. So if there's, I know that all the lightning speakers, we all had to real quickly snapshot, but if people, but if folks have questions on what we talked about. Yes, please.
You mentioned we need your support.
Yes.
What kind of support are you looking for?
Yeah. So it depends on what people are interested in working on. We have software projects that need contribution. There's a few strategic items I mentioned before. I think I'm looking for people who do grid deployments, common test protocols. I think there's a lot of new projects can be defined just from how do we get proper representation from grid deployments in this model. So it depends on, so there's so many things. It's just, it depends on where you see yourselves fitting in. Hope that helps. Yeah. Cool. Oh, yes, please.
You mentioned about the openness to share data.
Yes. Yes.
I'm not sure whether you covered it, but I was interested in what influences the openness of the.
Yeah. Yeah. So in the battery world, it's just not in the motion. So I think the software industry is very blessed in that there's a very strong open source movement that at the impetus was there. That was not present when batteries were being built. It's more akin to, I think Coca-Cola has a secret formula. Every battery company treats every aspect of their build as a part of their secret formula. And so it's just not in the culture. So the way kind of around that is the proposal of any kind of data sharing or data hub that has to be created needs to take into account that kind of cultural element and the restrictive nature of. So what we show on the left here is a kind of what we call from the battery data genome, they defined a data hub, and that it can be partially shared. There can be aspects of it that are never shared, that are kept behind four walls, but then there's aspects of the data that is shared. So we have to be very clear when we define, say, any data format, which columns are meant to go where, kind of things, right? Which things are actually critical for some R&D project and which are not. And then even if you are, not sharing, you can still apply the same format so that if someone were, to switch jobs or, to, move between organizations, they're not learning a new whole tech stack. It's, So there's different aspects of sharing. You think of, yeah. Oh yeah, very much so. Yeah, China's in the lead in terms of manufacturing. That's a tougher one. So when I had the list of kind of software companies, these are all North America or EU based companies. We didn't look into Chinese companies per se. So that's what this sampling is of. Yeah. Cool. But yeah, if you want to talk batteries, I'm here. So cool. Well, thank you all. We're at break now.